In this lesson, we're going to learn what a piecewise function is, how it can be applied to real-life situations. By definition, a piecewise function is basically multiple functions that are put together as a single formula, and they will each have domains based off of their specific output. You will use these in situations where a rule changes as the input value crosses certain boundaries. So for example, in real life, you have a lot of piecewise functions that you don't realize you actually will be using. For example, in bulk pricing, a company sells t-shirts for $10, but if you purchase between $11 and $50, they only cost $8, and if you purchase more than $50, they only cost $6. That's technically a piecewise. Based off of the domain of being how many shirts, then the price that you'll have to pay is going to change. Same thing with a tax bracket. If you only make up to $10,000, then you're only taxed at a certain percent. And then anything above $10,000, you'll be taxed at a different percent. So the domain and formula will actually change. So by definition, a piecewise function is going to be represented by different formulas, and each one of those formulas is going to have its own domain. The most common piecewise function that we don't realize we use is actually the absolute value. The absolute value function is technically the piecewise function of the function y equals negative x, as long as you are on the left side of the y-axis, basically. If the x values are negative, that means you plug it into the formula y equals negative x. And if the values are positive, then you'll plug it into the formula y equals x. So for example, if I have negative 5, if x equals negative 5, that is in this domain, which means I'll plug it into this number. So a negative times a negative 5 is how it actually turns positive. And if I wanted to actually know when x equals 5, that is inside this domain, which means I plug in 5 into the x, which is actually how I also get 5. So the absolute value function is actually a piecewise function. So let's actually write the piecewise function for what we were looking at a minute ago. So we could represent f of x, where x is the amount of shirts. So x represents the amount of t-shirts bought. So we know that if we buy t-shirts up to 10 t-shirts, so we're looking from, technically I guess you could say 0, even though if it's 0 shirts you're not buying any, up to 10 shirts, then it's going to cost you $10 per shirt. Now, if you are buying between 11 and 50 shirts, then it's only going to cost $8 per shirt. And if you purchase more than 50, meaning 51 shirts or more, because you can't have a decimal, you can't have 50 and a half shirts, so that's why we can just keep it as the next whole number, then it's only going to cost $6 per shirt. And that is a piecewise function. The tax bracket is actually a little bit different. So again, if we do f of x, where in this case, x is going to represent your income amount. Okay, so first, income up to is going to be 10% of your income. So 10% is 0.10 of your income, and that is going to be between 0 and $10,000. It does include $10,000, and so we are going to put lines underneath. So that's pretty straightforward. Here's where it gets a little bit different. Let's say that it's $11,000. You actually aren't taxed 20% of the full amount. You're taxed 10% of the first $10,000, And then you're taxed 20% of what's left. So if you have $11,000, you're going to be taxed 20% of just $1,000, if that makes sense. So again, let's just say it's $11,000. Only the first 10%, only the first 10,000 gets taxed at 10%. Then anything additional, which is $1,000 in this case, is taxed at 20%. Again, the 20% is not all of $11,000. It's only what's additional. So the way you would write it is 10% of your first $10,000, again, because we're talking about anything higher, plus 20% of whatever amount is left over after $10,000. Because you see how we got the $1,000? We got it because we subtracted 11,000 minus 10,000. That's how we got 1,000 that's left. That was the additional. And that is for anything greater than $10,000. We don't start with 11,000 because there are decimals. So anything bigger than 10,000, meaning 10,001, 10,002, $10,003, $10,000 and 1 penny. Anything over that gets to be this new. So that's why you don't just do the next whole number because of the decimal. You just do greater than the previous and don't put a line underneath. So what does the following piecewise function mean? We have a cell phone company that uses this piecewise function. The C is the cost and G is the gigabytes. So what does this represent? So basically it's saying that if you use up to 2 gigabytes, then it's only going to cost $25. If you use 2 gig or more, then it's going to cost $25 plus $10 for each gig over it. So now let's actually do a couple problems. How much would it cost for 5 gigs? So we're looking for where does 5 fit in the domain? 5 fits in this domain right here because 5 is greater than 2, which means we are going to take 5 and we are going to plug it in into the second function. So we'll have 25 plus 10 times 3, which means we'll have 25 plus 30, which means it is going to cost $55 for that amount of gig transfer. Next, we're looking for 1 gig. Okay, which domain is 1 going to be in? And that is going to be in this first one. The 5 is inside here, 1's inside here, which means automatically it is only going to cost $25. So a museum charges $5 per person for a guided tour if you have a 1 to 9 number of people. Or it's going to be a fixed fee for a group of 10 or more. So the first thing I'm going to do is write a function. So cost of C and people N. So this is going to be C of N because N is the number of people and C is the cost. So it is going to be 5 per person. So 5N if you have between 1 and 9 people. Got to have line underneath because it does include 1 and does include 9 people. The next one is going to be just a fixed fee, which means it's just going to be $50 period. It's not multiplied by anything. A fixed fee means it doesn't change. So it is just going to be if N is greater than 9. Or you could say 10 or more. because these are whole numbers. You can't have 9.5 people. So you could use either one. It's going to be the same. So the first thing is they want to know the cost for 5 people. Well, you're looking for which domain is 5 people. 5 is going to be inside this domain. So you'll actually plug 5 into N. So 5 times 5 means it is going to cost $25 for 5 people. 15 people is inside this domain, which means your answer is automatically $50, no matter what. So to examine, let's go ahead and actually do a couple of these. We're looking for which domain these are in. So -5 is going to be inside the domain of the 2x minus 10, which means I'm going to plug in -5 into my first function, which means I will get -10 minus 10, which is -20. -2, okay, so -2 is actually the number, so you're looking for which one includes the -2, which is the bottom function. So I'm going to plug -2 squared plus 1, which is going to give me a +5, because negative squared is positive. And then 6 is also going to be in the second function. So 6 squared plus 1 is going to give me 37. So same thing, we're looking for where the domain is going to be. So pause the video, attempt to do these problems, and then hit resume to check your answers. So 5 is in the domain of x is greater than 2, which means you are going to use the third function, which means your answer is going to be -20. -3, all right, is actually a number that's used in 2 different formulas, so you're looking for the one that has a line underneath, which means you're looking for the second one, which is going to be -10. And last, the 2 is in 2 different formulas, so again, you're looking for the line underneath, which is also the middle function, which is going to be 5.